Okay, this is 14.2, the flaws of the voting system, part 1. This section is going to definitely be broken up because some of the problems take a while to explain. So we saw from the last section that depending on which method you use, it may produce a different winner. And although the methods we have learned so far are reasonable methods, all of them are flawed. So there are 4 criteria that mathematicians and political scientists have agreed that the method should meet to be considered fair. These 4 criteria are known as the fairness criteria, and they are the majority criterion, head-to-head criterion, the monotonicity criterion, and finally the irrelevant alternatives criterion. So because of these 4 criteria, you'll see that all of the methods will violate one of them. So there isn't a perfect voting method out there, and that's one of the takeaways from this section. So let's look at the first one, the majority criterion. The majority criterion states, if a candidate receives a majority, which is more than 50% of first place votes, that candidate should be declared the winner. So let's look at this example. The members of the Mumford Town Board are holding an election to select a company to maintain the lawn located at the town's community center. The choices are Allen Lawn Care, which is A, B&N Lawn Care Maintenance, which is B, the Maison Lawn Maintenance, which is M. The 15 board members rank the 3 choices and then use the border count method to make their selection. The preference table is shown in table 14.15. Part A says which company is chosen using the border count method, and Part B, does the winner from Part A have the majority of first place votes? Okay, so let's go ahead and do this. So Part A, we're going to use the border count method. And remember, the border count method basically relies on you having to give or rank candidates. So it's a ranking system. So if you get first place, in this case, since there's only 3 candidates, first place will receive 3 points, second place gets 2 points, and third place gets 1 point. So let's go ahead and write each one down. So let's look at A first. So candidate A. So if we look at the first column, we see that A has received first place. So A gets 8 votes at first place. We're going to multiply that by 3 plus. Then we look down the next column. A is in last place. So those 4 votes get multiplied by 1 because last place gets 1 vote. And or 1 point rather. And then the last column is 3 votes at stake. And A came in second place, so I multiply that by 2. So what do I get? I get 24 plus 4 plus 6. So 24 plus 10 gives me 34. Okay, so that's A. So let's look at B. So I'm going to erase all my marks and we'll check it out again. So we look at the first column, and B came in second place. So the 8 votes get multiplied by 2 for second place. In the next column over, B is in first place. So those 4 votes get multiplied by 3. And then in the last column, B is in first place again. So those 3 votes get multiplied by 3. So I get 16 plus 12 plus 9. 16 and 12 will give me 28. And then add 9 to that, and you'll see we get 37. Okay, and finally, we have to go through this process and figure out, using the border count method, how many points does C get? Okay, so same thing, look through each column, and it shouldn't be C, I need M, sorry about that. All right, so we're looking at M. So the 8 votes, the preference, M was in third place, so we're going to multiply that by 1. In the next column, we see that those 4 votes are going to be multiplied by 2 because M is in second place. And finally, in the last column, we see M is in last place, so those 3 votes get multiplied by 1. So we get 8 plus 3. So we get 16 plus 3, which equals 19. So the winner using the border count method would be B. So the winner is B, which B was B&N Lawn Care Maintenance. Okay, so part B says, hey, does the winner from part A have the majority of first place votes? So if we look at the majority or the polarity method, we're just looking at the first place votes. And we see that if we look at that, A has 8 votes and B has 7. So the winner is A. And this is an issue because the border count method produced the winner as B. So does it violate, or does the winner from part A have the majority of first place votes? The answer is no, it does not. So there's a violation there. So border count can violate the majority criteria or majority fairness criteria. All right, let's look at the next problem here. The preference table 14.16 shows the outcome of 33 votes. Decide which candidate would be chosen if each of the following voting methods. Also discuss whether or not the method violates the majority criterion. So we're going to look at A. So A is a polarity method, and this one's going to take us some time. I'm not going to lie to you. Or not this one. Sorry, I thought it was pairwise. I don't know what the heck I'm thinking. So let's go ahead and do part A quickly. This is polarity. And remember, with this method, we're just looking at first place votes, and we're determining who's the winner. And if I look here, A has 17, B has 9, and C has 7. So the winner with the most votes is A. Okay, so does that violate majority criterion? No, because they have the most votes using the polarity method. Okay, so that's fine. Let's look at part B. Part B says, hey, use the border count method. Okay, so remember that's the ranking. So first place will get 3, second place will get 2 points, and third place will get 1 point. So we're going to go through this. A has 17 votes at first place, so it gets multiplied by 3. And then in the next column, A is in third place, so 9 votes times 1. And the third column, 7 votes are at stake, and A is in third place, so it gets multiplied by 1. So when we do this, we get 17 times 3, which is 51, plus 9, plus 7. And we multiply that together, we get 67. Okay, and then do B. So once again, we're looking through each column. So there's 17 votes at stake. B came in second place, so it gets 2 points multiplied. In the next column, there's 9 votes at stake. B gets first place, so 9 times 3. And in the third column, B came in second place, so 7 times 2. Okay, so 17 times 2 is 34, plus 9 times 3, which is 27, plus 14. When I add those all together, I get 75. Okay. And then let's do C. So C, using the border count method, in first place, or the 17 votes, they're in last place. So 17 times 1. In the next column, C is in second place, so 9 times 2. And in the third column, C is in first place, so 7 times 3. Okay, so what do I get? I get 17 plus 18 plus 21. And if I add those together, I'm going to get 56. So here are the candidates. And we can see that the winner with the most votes using border count method would be B. So does that violate the majority criterion? Remember, with the polarity method, the winner is A. So this winner is B. So yes, it does violate. Okay, it violates it because our winner is not A. Okay? All right, so we got A and B done. So let's check out C. Polarity with elimination. So polarity says that you have to take and they have to win the majority of the vote. Remember that candidate has to have 50% or more of the vote to be declared the winner. And if it's not, then you kick out the person with the least amount of votes and you look at the preference table again. So when we did the polarity method the first time around, we saw A was the winner. So A was a winner. So basically we just have to check to make sure A has the majority of votes. So we take and divide 17 by 33. And when we do that, we get a decimal value of 0.1 or 0.515. So changing that to percent, I get 51.5%. Since that's over 50%, I don't have to do anything more. A is the winner. So if A is the winner, does that violate the majority criterion? No, it does not, because we want A to be the winner if you're looking at that method. Okay, now we have the pairwise comparison. Okay, so pairwise comparison, I'm going to put D here. Remember, that's versus. So those are rounds that we have to do. So we have 3 candidates, so n equals 3. And to figure out how many rounds we have, we take 3 times 3 minus 1, which is 2, over 2. So remember, the formula is n times n minus 1 over 2. So I get 6 over 2, so we know we have 3 different rounds. So I told you to look at the first column and just start writing those down. So we have A versus B, and then we have A versus C, okay? Now we go down to B, B versus C. So I have all 3 unique rounds. So what I'm going to do is look through each and every column and see who gets the votes. Okay, so we're going to start with A. Look at the first column here. So this is going to be A versus B. So if I look at the first column, A has first place, B has second place, A gets votes, so they get 17. I'm looking at the next column. B is in first place, A is in third place, so B gets a vote of 9. And then the last column, B has second place, A has third place, so since B is of higher ranking, B gets the 7 points. So when I add those together, I get 9 plus 7, which is 16. A is the winner. So that means A gets 1 point. Okay, let's check out A versus C. So we know that A, if we look at the first column here, is going to be the winner again. So they get declared the 17 votes go to them. In the second column, C is in second, A is in third, so C gets the points. So we're going to give 9 here. And then in the third column, because A has last place, C beats it because it's in first place, so the 7 votes go to C. So A is the winner again. So A is awarded 1 point. Now let's do B versus C. So last one. So once again, look through each column and award the points to the person that has the highest ranking. So if I look at this, B is in second place, C is in third place, so B is the winner. So B gets the 17 points. The next one, B is in first place, C is in second, so B is awarded those points, so they get 9. And then the last column, B is over A, or C is over B, so C gets first place, B gets second place, C gets the points of 7. So 17 plus 9 is 26. So in this case, B is the winner. So B is awarded 1 point. So with this method, what you have to do is you have to tally up the points. So A has a total of 2 points, B has 1 point, and C has 0 points. So the winner, or the overall winner, is A. And remember that A won the majority, so does it violate the majority criterion? No, because with the majority criterion, you'd expect A to be the winner. And that's how you do the pairwise comparison for that. All right. I'm just going to read over objective number 2, and I think we should stop because the video is going to get too long. So objective 2 says head-to-head criterion. So this is the next fairness criterion. So we saw majority, now we're seeing head-to-head. If a candidate is favored when comparing head-to-head with every other candidate, that candidate should be declared the winner. To figure that out, you're going to have to use the pairwise comparison. So this is also called the Condorcet criterion. So what I'm going to do is in the next video, we're going to start right on this example and we'll work through A through E. All right, so this is the first video. Once again, you're going to have to watch probably 3 or 4 videos for this section.